like it has been said, I have just 10 minutes, so there's no story here. The soil laboratory, actually, initially when I received this notice, and it was captioned seminar. I don't know, is it really a seminar or an awareness talk? So I would rather adopt awareness talk. The soil lab, as we all know, I don't have time for story. Let me just go straight. The soil laboratory in NIHOT is one of the major labs that we have within the system. And the responsibility is well defined. Our major focus is on soil, which is a major factor of production. And the soil that we work with, we need to carry out some analysis. The physical analysis, the chemical analysis, and even if time permits, it is expected that we will carry out a biological analysis. But as it is today, we are only dealing with the physical and the chemical analysis as of today. I don't need to define soil. We know soil. The essence of carrying out this analysis is for us to know or to have a deeper understanding of the properties, behaviors, and the potential applications of the soil. Then the determination of the nutrients, status of the soil, the acidity, the alkalinity, organic matter, content, soil moisture, soil texture, etc., etc. Those are the things we are supposed to work on or to find out from the soil, and that we are doing. Apart from the fact that we carry out all those analyses, it is also important, very necessary, because it has other applications, especially in construction industry, determination of soil, heavy metal deposits, and then also even in engineering industry, they carry out soil analysis. Even in road construction, they carry out soil analysis to know the kind of soil to be applied or to be used. The major parameters that we handle or we work on: pH determination. Of course, we know pH, that is acidity, alkalinity of the soil. And the importance of that, we all know, or I expect us to know. If a soil is highly acidic, definitely it's going to inhibit the absorption rate of the nutrients by the plants. If it is highly alkaline, also, it's also going to inhibit. So it must be within the range of maybe 6 to 7.5, the pH. At that rate, the soil nutrients will be at good advantage for absorption by the plants. Then mechanical analysis. This is just a particle size analysis of the soil. We want to know, and the essence of this is for us to also know the kind of crop that's supposed to be grown in that type of soil. We want to know whether the soil is rich or it is not rich enough for crop support or growth and development. Organic carbon, organic matter determination, these are some of the things we carry out in the soil lab. Total nitrogen, fluoride determination, these are some of the things that we also carry out in the soil. Then nitrate in the soil, available phosphorus, etc. etc. There are so many other parameters that we can carry out in the soil, depending on the request or the need for that analysis. Then phases of the soil analysis, collection of the soil sample. Sometimes we go to the field ourselves, we collect the sample. Sometimes samples are collected from different locations, from different states of differentiation, and brought to the lab. I can remember Dr. Ikume brought some samples, about 2 or 4 samples for mechanical analysis. The other time you are doing your PhD work, sir. And we carry out everything in the soil laboratory. Extraction, then determination of all the available nutrients. After we have collected the sample, then you carry out the analytical work to find out what the soils are made of, the nutrients, residual nutrients that are there. And this information is very also vital because it will help the farmers to know the nutritional status of the soil. Are we to apply fertilizer? What rate of fertilizer or quantum of fertilizer to be applied? So the information is very, very vital. And then you interpret your data and then you formulate your fertilizer application. And for the scientists that want to go ahead and then they can make their judgment based on the laboratory results. Well, I've said some of the facilities in the lab presently that we are working with, we have the pH meter. That one is functional. As of today, it's functional. It's working. So we can carry out, we can determine acidity, alkalinity of samples, be it plant samples or soil sample. We also have a functional distiller presently in the lab. In fact, just yesterday, some students from Technical University, Oyo State, came to buy some distilled water in the lab. So that one is functional and operational, is operating well. Then mechanical analysis. These are some of the facilities that we need to carry out the analysis. We have the glucose star, the soil hydrometer, and the thermometer. All these 3 components are working well. We don't have issue with them. So if anybody has samples and they want to carry out mechanical analysis, we can handle it without any problem. They are all functioning. We also have recently, kudos to the management, they procured a deionizers for us in the lab. So apart from distilled water, we can also generate deionized water for our analytical work in the lab. So I'm saying this for the benefit of some of you that doesn't know that we have a functional deionizers in the lab. So some of your friends outside here, or for your research work that you want to carry out, analytical research work, we have all these facilities at our disposal. Then of course, we have, you can carry out your moisture content, we have your dry matter content, we have our oven in the lab. Though the oven presently is not working 100% because the temperature gauge is not 2 of them. We have 3 in the lab presently. The only one is reliable. The other 2, in fact, one is not even being used at all. The other one manageable in a very minimal level. Only one is dependable. Of course, we have weight balances and we have analytical balance in the lab that are functional. We don't have issue with that. So, but also, we always have people that bring samples to the lab for weighing, and we have never been charging anybody for that. But I remember sometime I was at, I will not mention the lab outside here. If you want to weigh your sample, you pay. But we are doing that free of charge here. As soon as sample, we have a functional mobile furnace. We don't have issue with that one. It's working perfectly. So for ashing of our samples for further chemistry or chemical analysis or elemental analysis. Then we have fairly good, I will say, fairly good. We have two actually. We have two flame photometers in the lab. One was procured, I think, about around 2017 or 2018, but that one never worked. It's not good. Nachinko, so it's not functioning. But this one is almost as good as NIHOX, and it has been overused. But it's fairly good. But it needs replacement if there's fault for that. Because sometimes you have large volume of work to handle with or to deal with. And if you depend on this, it may break down suddenly. We don't pray for that, but it's an guys. That is still fundamental. Of course, we have AAS, Atomic Absorption Spectrophotometer, but it's not working. It was procured in 2017, January or February. I can't remember. But it never worked. It's not functioning. The system is blind following the lab there. Then these are some of our constraints anyway. Like I said the other time, there are so many parameters that we can work with or can handle. But if only we can be provided with UV spec. And I think at our meeting yesterday with the executive director, I think there's a green light that some of these things is coming. We pray it will come very fast so that we can commence our work. The film cover also needs repair or total replacement. And at our meeting with GT yesterday, it was also trashed. There's also a green light in that direction. Very soon we'll have them by God's grace. Then the necessary consumables or reagent that we need to perfectly carry out all the above-mentioned parameters. So, and I just want to say thank you for this opportunity. Thank you for the opportunity to let the House know what the solar stands for, or what we are doing, and what we are expected to do if all these items are provided for us. The phosphorus in soil, and other things we can do. Nitrate we can do, carbon, organic carbon we can do. So please, we urge the management to give it consideration so that all the things that we discussed yesterday will come. Thank you.
Thank you very much. You've spent 11 minutes. I intended to stop you at 10 minutes, but I realize that you are at the tail end. So we really appreciate that. Thank you so much. Please, clapping. Thank you so much. Let the second person please take the podium. Please, whatever questions you have, please jot them down. I know we have a series of questions, and I want us to take them at once. Please, let us manage our time. Then let's focus on the major area of what we intend to discuss. Existing equipment, what we can add, how to upgrade the one that we have. Thank you.
Good afternoon, everyone. Still on an existing protocol. I'm here to present the biochemistry laboratory, as the subtitle as dissemination of information on existing equipment. These are the outline. Introduction. Biochemistry laboratory plays a fundamental and in advancing scientific research by exploring the chemical processes. The objective of biochemistry laboratory is to support the scientific research. The aim of this presentation is to highlight the existing equipment within our institute. And the goal of this presentation is to present a clear path to ensure the laboratory is fully functional, support the progress of the institute, and product development program. Current state and challenges of the laboratory. The biochemistry laboratory is currently functioning, but there are certain limitations which are causing setback in carrying out some analysis. These are the available equipment. We have UV spectrophotometer, visible spectrophotometer. The difference is that this UV spectrophotometer is not functioning for now. I believe that it will still be repaired because it can only be used when you have analysis that is below 400. Then the visible spectrophotometer nanometer. So the visible spectrophotometer is limited to 400 nanometer. So that is the difference between them. And this is sensitive analytical balance. This one can only be, we always use it for when we want to weigh standard. Then this is weighing balance, we use it to weigh samples because it can weigh more than 0.1 couple. And this is protein analyzer. We can use this one to distill protein when we want to determine protein. And it was just recently installed. It has not been used. And then with Susslet apparatus. This is refractometer. It can only be used when you want to determine the level of sugar. You cannot just say that the sugar content of this thing is high. You can only be quantified with the use of refractometer. Table pH meter. This one can be used when you want to determine your acidity and alkalinity. The centrifuge also can be used to separate the mixture in the samples, including water baths. Film cupboard. This film cupboard here is not functioning. So this is one of the limitations that we are facing in biochemistry lab. So this film cupboard can also be, it can just be used when you want to digest your sample. So without it, we cannot do anything. That is why the protein analyzer is still there. Because without this film cupboard to extract the film, we cannot further any work. This is distiller. The distiller can be used to distill water because you cannot just use any water in analyzing in laboratory. This is portable colorimeter. This portable colorimeter can read color. You cannot just say that, oh, you have different varieties of cucumber, but you know quietly that it's green, but you have to quantify it with the use of portable colorimeter. And this is oven. These are the analyses carried out in biochemistry lab. The first one is phytochemical analysis, physicochemical analysis, and cosmic analysis. The parameters in phytochemical analysis. These phytochemicals can be categorized into two places. We can carry out the antioxidant property and anti-nutritional property. The antioxidant properties, these are the parameters that you have to carry out on them, like total phenolic compound, total flavonoid, total antioxidant capacity, total carotenoid, lycopene.
Sorry. Who is rapporteur for your
Then the ascorbic acid. For the anti-nutritional property, you can carry out the tannine, phytates, and saponin, and oxalates. You know, there is need to carry out all this analysis in food samples, antioxidants. As we all know that our mandate here is fruits and vegetables, and these fruits and vegetables are very rich in antioxidants. So we have to carry out all this on them. Like tomatoes now, lycopene is biotic compound in tomatoes. So we guys need to carry out all this on them. Then also we have vegetables. These vegetables also are somehow high in some anti-nutritional, which is not too good for human consumption, but with limits, with acceptable range. So that's why you have to carry out like ugun, this bitter leaf. So that's why you have to carry out some things like, some parameters like tannine, phytates, saponin. Then these are the parameters in physicochemical. We can carry out the total soluble solids, as I said earlier on. Then the titrable acidity, you have to carry out on them. We can carry out this in biochemistry lab, the pH and color. Parameters in proximates. We can, with the supply of this protein analyzer, we should be able to carry out the crude protein, the fats, moisture content, crude fiber, ash, and carbohydrates. Meanwhile, we don't have multiple furnace for now, which I believe they will soon supply it, the multiple furnace, and with the sourcelets, the bigger one, because the one supplied is just too small. It can only be used for only one sample. But when you have many samples, that means, and that's for one sample, you have to spend like 4 to 5 hours. Recommendation: frequent maintenance. We need to be doing this routine service. Routine service on this equipment that we are talking about. Then, essential consumable. There is need to stock up all necessary chemicals, reagents, and glassware to begin operations. Availability of standard. Provision of chemical standard. You know, all these parameters that I talk about, like all these biotic compound, each of them has their own standard. Like now, you want to carry out pepper. You know, we all know that pepper is the biotic compound in pepper is called capsaicin. So we need to carry out this with the use of the standard. And the standard, when you are doing it, you have to be very careful, because it's just like pepper. You have to put on all your safety materials. So like that, we need the standard for it. Like onions also. Onions also have its own biotic compound, which is called pyruvic acid.
Use your laptop.
Okay. As I was saying, like onions, the biotic compound in onions is called pyruvic acid. So we need the standard for that too, so that you're able to teach students. When they are no more, there's nobody to support us. And most of our work that we are doing are very tedious.
Thank you so much. Please, you can have your seat. When the question arises, you attend to them. Before my chief executive came in,